Thanks for the invitation to present this webinar today, and thanks for the introduction. I'm happy to present Tozo's two-step purification platform that allows to halve the costs of your antibody purification. Short glance at who we are first. Tozo Bioscience GmbH is part of the Tozo Group. Tozo is one of the largest Japanese chemical company, founded in 1935. It operates 107 companies worldwide. Today, Tozo belongs to the top chemical companies in the world. We are a market leader for many building blocks of our everyday life. Look around you, it is almost impossible to find a manufactured item that does not include something from Tozo. Your smartphone, your house, your life-saving medicines rely on Tozo's expertise. Worldwide, more than 13,000 people are working for the Tozo Group, 10% of them in research and development, and last year we generated over $7 billion in revenue globally. Since 2015, the European headquarters for the chromatography products, including a large application lab, is located in Griesheim, in the Rhine-Main area in Germany. We are responsible for the distribution and support of TSK gel, HPLC and UHPLC columns, ToyoPearl process media, and GPC, SEC instruments and MELS detectors in the EMEA region. At Tozo, our mission is to enable our biopharma partners, which means you, to provide safe and efficient therapies against life-threatening diseases through a team of chromatography experts. Let's dive into how our mission translates into the purification of antibodies. Standard downstream process for antibodies always starts with protein capturing after the upstream. Protein chromatography typically allows reaching purity over 95% while getting rid of host cell proteins and DNA. And the most typical polishing step after protein A consists of cation exchange chromatography, which focuses on removing antibody aggregates, host cell proteins, and protein A leaching, followed by anion exchange to remove DNA, host cell proteins, and protein A leaching, even if it offers a lower log reduction for protein A leaching than cation exchange. So, as mentioned before, the first step is protein capturing. In order to have an efficient process, it is best to start with an efficient step with high yield. You don't want to lose antibodies directly at the beginning. And that's where the ToyoPearl Protein A HC resin is good at. It gives you a high purity, keeping a very high yield, at 98.8% in our case, where we purified adalimumab, while reducing DNA from 11,000 nanograms per milliliter to approximately 600 nanograms per milliliter. And also reducing host cell proteins from 550,000 ppm down to 19,000 ppm. An even bigger advantage of ToyoPearl Protein A is its stability, which allows to have this high performance while keeping the level of leach protein A very low, in our case around 5 ppm. So just to summarize where we are into the process. After the antibodies have been captured via protein A and eluted at low pH, we would typically hold the eluate at pH 3 to reduce the virus contamination before moving to the polishing steps. And now the question is how to get rid of one of the polishing steps. At Tozo, we developed an anion exchange resin which does the job of typical anion exchange resins, removing protein A leaching, DNA, and host cell proteins. But we also managed to make it do the job of cation exchange resins, removing aggregates. Using this salt-tolerant ToyoPearl NH2 resin allowed us to replace both cation and anion exchange steps by a single anion exchange step. Now let's see how we use this resin in our process. The first step we had to do was to inject the antibody eluate from the virus hold and to perform a linear salt gradient to determine at which conductivity the monomer and the aggregates are eluting. Here, the monomer elutates around 20 to 25 millisiemens per centimeter, and we are in the optimal condition that the monomer elutates first, allowing the development of a flow-through method with a loading conductivity between 20 and 25 millisiemens per centimeter. So once again, we injected the feed from upstream after clarification on our protein A resin. We submitted the yield rate to a virus reduction through a low pH hold, and we went into the development of our flow-through anion exchange step. What we need to take a look into now is in terms of loading conductivity. What is the best conductivity to use in order to have the best performance? Therefore, we investigated 3 conductivities between 20 and 25 millisiemens per centimeter, as we identified on our linear gradient experiments, to develop our step gradient. And here is a chromatogram of the flow-through polishing step on the salt-tolerant Toyo-Pearl NH2 750F resin. By selecting the right conductivity for the different steps in our gradient development, we could have the monomer flow through the column, whereas the aggregates bind to the resin and elute during cleaning in place. Let's investigate the performance of the method. At first, there is always a trade-off between purity and yield. So we took a look into the aggregate content and the yield of this step. You can see here that whereas the purity is very high, with 0% aggregate at 20 millisiemens per centimeter, the yield of this step is only of 91.3%. And if you increase the conductivity, for sure you increase your yields, but also you decrease the purity. And the idea was that we kept the purity as high as possible while accepting that the yield would be a little bit lower. So we continued working at 20 millisiemens per centimeter. And that's good because we see that the anion exchanger is doing the same job as a cation exchange resin in reducing the aggregate content to 0. And as we have only 2 chromatography steps, the overall yields will anyhow remain high. But we have another question to ask ourselves. How about the other critical parameters that should be taken into consideration during the polishing step? And here is a summary of the critical parameters in the feed after the protein A step and after the single polishing step on the salt-tolerant anion exchange resin at 20 millisiemens per centimeter loading conductivity. So you see that the aggregate level drops down to 0 after that process. And in terms of yield, if you remember, we were at 91.3% just for the anion exchange step only. But since the TOSOS protein A HC offers very high yield, we obtain an overall yield of 85% by the end of the last chromatography steps. And in terms of DNA, host cell proteins, and leach protein A, we are always below the limits of detection for all 3 quality parameters at the end of our 2-step process. So for sure, as I mentioned before, the high performance and high stability of the Toyo-Pearl protein A resin facilitates the subsequent steps, and especially the low leaching simplifies the polishing. But the simplification of the overall DSP process could only be achieved because the anion exchange that we developed, Toyo-Pearl NH2 750F, can reduce the aggregates as good as cation exchangers and delivers very good results in terms of critical parameters. Now, what about the impact of these changes to the overall process? We decided to use a modeling solution, which is called BioSolve. BioSolve is a leading process analysis and economic modeling package for the biopharmaceutical industry. The big advantage of BioSolve is that it doesn't take into account only a couple of cost parameters in the process, but it takes into account all the aspects of a process. For example, capital investment, material costs, consumables, or labor. Another positive aspect of working with BioSolve is that they partnered with BioForum, which is a collaboration between several biopharma industries. And this group of industries shared information with BioSolve to implement their manufacturing technology roadmap into the software. This means that as a basis for all our calculations, we could use the state-of-the-art processes, technologies, and prices which are used in the industry. So how does it look like? The first comment here. You will see dummy production at the very beginning of the graph, and it's because we didn't take into account the costs for upstream, as we kept it the same for both purification processes. We focused on the downstream steps only. So what flows into the overall costs for the production of MABs here? You have all the standard steps of the downstream process: protein A, virus inactivation, cation exchange, anion exchange, most of the time in flow-through. And those are all the 4 steps we've been speaking about before. And that's followed by virus filtration, UFDF, and final filtration. So if we take a look into the figures, here is a breakdown. You can see that with their 3-step chromatography purification process, you reach a cost per gram antibody for the downstream processing only of almost $45. And if we compare it now with the TOZO process, this is how it looks. The first obvious change is that we removed one of the steps. There is no cation exchange step between virus inactivation and anion exchange, and all the other costs changed as well. We really only took the same process as before, and we entered it into Biosolve the parameters that we got out of our experiments for protein A and anion exchange. And these changes in terms of yields, in terms of buffer, in terms of conditions for the chromatography steps, have an impact on all the other non-chromatographic steps in the process. How does it look like in comparison with a standard industry process? As you can see here, using the 2-step platform really benefits your costs of production. You increase your throughput from 717 to almost 1,800 kilo per year. And in terms of costs, you decrease your cost from $45 per gram of antibody to only $24 per gram of antibody, which represents a 45% reduction of the DSP costs. So working with the TOZO 2-step antibody purification platform gives you a huge number of advantages. You reach high purity, high yield, high productivity, high throughput, while reducing your costs. Coming now to the end, the last point I wanted to address today is just a question. Do you want to increase your productivity and to decrease your costs? If you want to test any of our resins, or if you want to discuss any of your needs for the purification of biomolecules, just drop me an email or contact me on LinkedIn. Thank you for joining this webinar today, and I'm looking forward to answering your questions.